Alright, welcome to Physics 184. We're still on Chapter 28. This is question number 10 for Mastering Physics, Chapter 28, Homework 6. So in this problem, we're asked in the following figure, what is the value of the potential at points A and B? So in opposite corners of each other, A and B. And notice, a big thing to notice is that we have this little symbol. That's not a battery, it's not a capacitor, That's what we call a ground, okay? So once a voltage passes through this point, or really when it passes through this area, it's going to be grounded. So then the voltage is going to be zero. The change in V is going to be zero, but it's grounded, right? So let's say we have, let's just say we're going this way in the loop. Let's just say we're going clockwise. You go here and whatever the voltage is, you get some random voltage, but once you pass this point, you're still going to have the same voltage as you got from after this battery. Once you pass this point to here, you're going to get zero. And same thing if you were going this way, right? But then this point would just be zero. Hopefully you guys will see what I mean more in the example. So we're just asked to find the value of the points A and B. So let's go ahead and find the current, because the current is a closed loop. So, Kirchhoff's loop rule. So I'm just going to start this battery, right? So the battery, let's just call this E1, E2, R1, R2. Okay, so we got E1 because we're going, let's just say we're going this way, clockwise. Like a moment, right? But E1, and then we're going for the resistor, so it's like a waterfall, right? Sliding down, so you got new minus, not R1, but I R1, because we're doing this in terms of a current. E equals to negative IR, just remember that rule right there. And then we're going backwards through a battery, right? This battery is not positioned the right way. We're going down a battery. We're going from positive to negative, so that's minus the battery. Normally it would be plus if it was positioned opposite the proper way. And we're gonna forget about the ground for now because that's gonna it's gonna mess everything up. Because that's just zero anyways, right? It's just gonna ground it and it doesn't do anything to it. So we're just gonna minus another resistor right here. So oops, we got the parentheses here. And equals zero. And we're back at the battery, right? So we're asked to find the current. I mean, this is good practice. This is how you find the current as well. But we can also find it just by directly multiplying it. So if we're trying to get to A, at point A, you always start at the ground, right? To find a potential difference, you always start the ground. But this one, let's might as well just finish this. We're not even asking this. I don't know why I did this, guys. But this is a good way, good practice, I guess. So we're just going to do 15 minus E2, which is minus 5. And then moving i's to the other side, we're going to factor the I, we'll get R1 plus R2. So that's just going to be 4 plus 1, which is 5. So 15 minus 5 is 10 equals to 5i. So the current is just going to be 2 amps. So do we need that? No, but is it cool to have? Yes. So, but you always want to start from the ground. You start from the lowest potential. Why? I don't know, but that's what you want to do. So that's 0 volts right here. We always start at ground, so that's 0 volts. Go for a bet, it's 5 volts. So A, it's 5, right? So because 0 volts plus 5 volts, okay? Now we can go the shortest route or go the longest route, right? Let's go left and let's get to point A by going, or I went this way, let's try going this way. So we're gonna have a resistor, right? Well, the resistor is equals to minus IR. No, we found I right here, okay? That's why I want to find this. We didn't really need to find it, but for point B we do. Okay, so I mean for point B you already know that's just gonna be what is it, -2, but let's just go this way to find A, right? So that's gonna be minus IR, so it's gonna be minus 2 times 1, which is gonna be -2 volts, okay? And we'll go for the battery plus the right way, so that's 15 volts. And then let's minus 4 times 2. And then we're at A, so 2 volts plus 15, well, that's just 13. And 13 minus 8, that is just going to be 5. So as you guys can see, no matter which way you go, as long as you keep it constant, whatever the word is. As long as you know your signs, you know which way your battery and your resistors going facing, you should be good. So again, point B, I'll redid it real quick here. If you go to the left straight through the resistor, that's just gonna be a minus IR. So that's just gonna be minus R2, which is just 1, and your current, which we found right here, which is 2. So it's negative 2 volts. Not back 9 volts. And here's the answer if you guys don't believe me. And yep, that's it.